So, guys, welcome back. Today is day 10 of 200 days DSA live DSA Python series. Okay, so guys, as you all know, this is a discussion which we will be doing together. I'm not going to give you any kind of lecture or anything which feels that it's kind of a class. No, that will not be the case. Instead, we will try to get more and more solution of any particular problem which we will be solving in this class, and will build the intuition, build the idea, build how to think in that direction that we are going to do. Okay. So this I'll be starting a Telegram channel very soon. So yesterday also I was telling you, but I couldn't start. I just need to create a group. Okay, I'll be creating a group by tomorrow, and I'll be rolling out the links for joining those groups. And in that group, I'll be posting certain questions which requires logical thinking, and you will be uh, you know I'll start from zero. I'll start from basics. Okay. And you will be solving, and in the evening, we if you insist, then we will be discussing those questions. Otherwise, I'll be telling you the solution in that group itself. Okay. So this is what is my idea, and let's start. So you can see here, it's lead code question number 189, and the question is, you have been given an integer array nums. Okay, you need to rotate the array to the right by k steps. Okay, and it is to mention that k has to be non-negative. Okay, let's try to think on those lines, guys. So what is the idea which I'm going to think here is, say if you want to uh, rotate any array by one place, what is the meaning of that? It means that if you rotate by right, it means that the last element on the right, it will come on the first position. Okay, so it will come on the 0th index of this nums. Okay, this is the idea. And that will be k equals 1, right? So k is basically how many times you're going to rotate the array. Okay, so rotate the array by k place means, if k is equal to 3, then this is the explanation given. All right, rotate the array. So you can see here 7, which was in the last, it came to the first position. Then 6th, which was the second last, it came to the first position, and 7 went to the second position or first index. Okay, let me just I'll just put this link on the group. And Okay. So just think on those lines. Can we start with the for loop? If we start with the for loop, then we'll just rotate that by 3 place, and we have to do some jumbling. That can be the idea. Or one very basic and normal approach can be it can be the so let's start thinking on those lines. So if we rotate, like if we want to put the last element in the first element, then what will we do? Um, we can think of we will just add the two array. So in Python, you must have studied about slicing, right? So can we slice and add? Okay, so nums of -1 will be 6. Yeah, nums of -1 will be 6, and I will add to 0 to n-1. That we can do. Can we do that? So this we will do 3 times. So if we do nums of -1 plus uh, nums of 0 up to n-1, can we write this? If we put this n-1, then it will go up to n-2. Okay. What is the output we are getting? I'll just say return, uh, let's say I'll make it result, and result is equal to this. I'll define it, then return result. Can I do this? It says n is not defined. Okay, because we are just experimenting, right? We will define n. Okay, this n-1, we can n is equal to len of nums. Okay. Can we do this? What is wrong in this? So what we can do is nums of -1. This is correct. Uh, and this should be so basically if we want to rotate by we can just do nums we can override. So if we want to rotate array by k, let's say k equals 3. So uh, what I want is 5, 6, 7 to be start. Okay, so index of 5 is 0, 1, 2. Okay, so fourth index I want to be a start. What I do is minus 1, minus 1, minus 2. So n minus 3 last, right? And column and this case 2 is qualified. Here, this one, 5, 6, 7, 1, 4, 5, 6, 7, I got. Uh, if you make it n minus k, because I want, no, yeah, now I'm getting. But not all test cases are getting passed. We have only 38 test cases getting passed, right? So you can see here what I want is I want all the test cases to be passed, right? Then only this gets submitted in lead code, this platform. Only then this gets submitted. So we have to think about it. Okay. So if you have this input 1 and 2 and k equals 7, then the output is coming something like this. So we have to resolve this now. One more thing we can point out is that k can be greater than, here see 7, k is greater than the mm, total nums. So what we can do is we need to have the multiple of um, so what idea I can put is, let's say this is the rotate k 3 times, I am getting this. If I rotate this nums how many times? 1, 2, 3, 4. Rotate it 7 times. What I'll get? I'll again get the same nums, right? So after rotating, the elements will come on the similar position, same position, right? After one full rotation, right? So if k is equal to 3, uh, we are getting this. But if k is equal to 7, okay, if k is 7, then we will get this nums again same. So what can be my thinkology in this reference? If k is 14, then again I will be getting the same number. So what it is, whatever is the k, okay, k percent length of nums, okay, this we will calculate, okay. And why we are calculating the percentage? Because it will actually find us out the remainder, okay. And whatever is the remainder, then only that much rotation of element will be done, because otherwise whatever is the divisible, let's say if we consider it k as 17, okay, so what will happen? I'll do k percent n, which is the length of nums, okay. So it will come 17 divided by, or you can say 17% 7, and the remainder will be 3. So we just have to rotate the nums, okay, by k percent n places only, okay. We don't have to repeat two times rotation, because we are getting the similar number, right? We are getting the similar number again and again, okay. That is the case. All right. So you have to think in that way, okay. So you have to think in such a way that it reduces your calculation, it reduces the burden on the compiler, right? That is the case, okay. Now, so we'll just put these conditions, okay. K is equal to k percent length of nums, or you can say n, okay. So what is the value of k? Now k is, I think this should do the yeah, can we submit it again? Yes, this solution is accepted. Why? Because when there was only two element, then what was happening? uh, it was returning 0, right? um, what was the value of k? The value of k was 7, and we had only two elements, okay. So it was rotating the element 7 times, but it was not required, okay. The required is k percent n times you have to do. So here, the if you do k percent n, then what is the value of n? N is 2, okay. So the remainder is coming 1. 7% 2 will be 1, right? So we just have to rotate by one place, that's it. Now we are getting the correct answer, and we are beating 100% of the time, right? uh, you can see here the memory allocation and the runtime, right? All 41 of 41 test cases are passed, right? So this was the medium question, okay, from lead code, and this is the solution. If you think about time complexity, what is time complexity? So this is getting rotated n minus k and 0 to n minus k, okay. So the total time complexity here will be n order of n. Okay, this will be the total time complexity. What is the space complexity? Space complexity will be order of 1 because we are not consuming any extra space. We are just using the space which was in the nums, right? So this is how we could able to do it. So guys, that's it for today. Just have a view on the solutions part, and if you come up with any different solution on this, feel free to message me, mail me, connect with me. Okay, I'm available on uh, LinkedIn as well as just comment on this video, and I'll see you in the next one. Okay, and if you want any particular video which I should cover from lead code, then guys, please feel free to ask me. So this is the day 10 of 200 days live DSA Python series. Okay, and I would invite you all for the discussion. Okay, so guys, that's it for today. See you tomorrow. Bye bye. Take care.